Now let's look at an example. Let's let S be the plane triangular region pictured here, where the triangle has vertices 1, 0, 0, 0, 2, 0, 0, 0, 3. And let's just let our f of x, y, z function be negative yi plus xz plus xz squared k. Now, as you see, I'm going to regret having chosen this just because there are a lot of plus and minus signs and coefficients to keep track of, so this gets a little bit not difficult but messy. And I'll warn you up front that my results don't reconcile well, so keep your eyes open, see if you can find my error. Look for errors because there are some. There have to be because my two results don't reconcile. I'll be looking too, so keep your eyes open, see if you can find it before I do. Or at least before you see me find it, assuming I do find it. So let's ask the first question. On this surface, what is the curl of f dot n? Now, there are two things we have to know. Curl of f, which is easy to calculate for an arbitrary x, y, z, but what's that look like if we confine ourselves to this surface? And then n, what's a normal vector to this surface? Now, you would think this is going to be fairly simple because if you think about it, the normal vector is the same at all points of any plane region, something you want to keep in mind. And this is a plane region, so we're going to have just a constant normal vector. That should make it simple, right? Okay. Now we go ahead and calculate the curl of f. This is the first place I'd better check myself for errors. We have I times the partial of this with respect to y. No y dependence here. Partial of z with respect to x. No x dependence. No z dependence here. So we have 0 times I. Then we have minus j times the partial with respect to z of negative y. Well, there's no z dependence in y. And the partial of x with respect to xz squared. Now it's going to be minus that. We've already got the minus. So the partial with respect to x of xz squared, again, double check me on this, is just z squared. It's z squared, but it's minus because it's here, and it's minus because it's a j, and without going into all the detail, we get z squared j. And then k times this one minus this one. Well, this is 1, and this is negative 1. 1 minus negative 1 is 2. So our curl of f, I believe, is just plain old z squared j plus 2k. Now, be on the alert for another error, but I believe this plane is simply described by x plus y over 2 plus z over 3 equals 1.